Welcome to this video. We're going to do a type of problem that's pretty common in physics classes. Here's our example. A red car moving at a speed v travels a distance s in a time t. How far does a blue car travel during a time 3t if the blue car is moving at a speed v over 2? Express your answer in terms of s. All right, first, what are we looking for? There's a red car, there's a blue car. We're looking for how far the blue car travels. How far means distance. All right, let's write some things down. We have red and blue. They told us for red, use the letter S to represent red's distance. They said use the letter V to represent red's average speed. And they said use the letter T to represent red's time. Okay, we know how these three things are related. There's an equation. On the left side, you put the speed that red has. We're calling that speed just v. In the numerator on the right, you put the distance that red has, which we're calling s. And then below, we put the time that red has, which we're calling t. Let's do the same thing for blue. Well, wait a second. Blue is a whole other story. That's a different car. Does it have the same speed? No. Blue is only traveling at half of red's speed. So it's v over 2, where v stands for red's speed. See that? V is in the red column. All right, so how long does blue travel? For how much time? Does it go for the same amount of time, t? No, it doesn't go for the same t. It goes for 3 times t. So blue's traveling for a lot longer, much longer trip. And what about blue's distance? Because we haven't put anything down for distance. Well, they don't tell us what to use for blue's distance. So you might be thinking, okay, well, let me just put an S down for blue. Is this right? Wait, this is wrong. S stands for red's distance, and blue could have a totally different distance that it travels. So because S is reserved for red, and because blue may not go the same distance, we have to use a different variable. We have to distinguish blue's distance from red's distance because they're different. So instead of using an S, we have to use something different like S sub b to represent blue's distance. Let's write down the equation relating v over 2, the speed, the time, and the distance that blue has. Blue's speed is v over 2, half red's speed. The distance blue travels we're calling sb. And the time that blue travels is 3 of red's times. Okay, how do we proceed from here? We remember, oh yeah, we're trying to solve for how far blue travels. We're trying to solve for blue's distance. So here's what you do. If you're trying to solve for distance, you isolate distance in this equation and in this equation. So the way we isolate distance is by multiplying both sides by 3t. That's how we get the denominator to cancel out. And now we have SB all by itself on the right, and the left side becomes this. I'm going to break apart 3 halves from VT, and that's something I'm allowed to do. Okay, now we have to go to the other side for red and isolate this distance. We multiply both sides by t. Whatever you do to one side, you must do to the other. And the t's cancel out. Here on the right, they cancel. And we're left with this. Is that our answer? Did we find the value? Did we find what SB is equal to? Well, the answer is yes, we have found what SB equals, but we've expressed that answer in terms of V and T. They want us to express the answer in terms of S. We have to change out V and T and write the answer using an S instead. Well, that's kind of weird. What's the relationship between V and T and S? We look back to the other side. Here's the S, and here's the VT. They are equal, which means wherever you see VT, you can replace it with what it equals S. Here's a VT, and I can replace it with what it equals, S. And this is our final answer. We've solved for blue's distance, and we've expressed that answer for blue's distance using an S, or in terms of S. So a couple questions. First, why did I only use a subscript for S sub b? I mean, none of these other things here, this doesn't have a subscript, not that one, these don't have subscripts. The first reason we use a subscript only for SB is because everything else was given to us. The problem said S is red's distance, V is its speed, T is red's time. The problem told us what the speed was for blue and the time for blue. SB was the only one that wasn't given, so we made up our own variable. The second question is, how did I know to isolate SB and S? Remember down in this step I said multiply both sides by 3t, that's how you get SB by itself. But how did I know to get SB all by itself in the first place? And here's the answer. SB is what we were trying to solve for. That's what they wanted you to calculate or to find, is SB. And that's why you isolated it. What about on this side for red? How did we know to isolate S? How did we know to get rid of the T's? And here's the reason. Here's how we know. We want to express our answer in terms of S, which means we're going to have to substitute an S in somewhere on the side of blue. We know we will have to substitute in an S, which means you need to know what S is equal to so that you can substitute in an S and express your answer in terms of S. Right? So if I didn't know what S equaled, I would not be able to plug it in right here. So that's how you solve these problems.